Today we're working on section 4.5, rational functions. Specifically, we're going to be looking at the asymptotes for these rational functions. Okay, so the first example I have here is f of x equals 4x plus 1 over 2x minus 6. We're going to be finding the vertical asymptotes, the horizontal asymptotes, and the oblique asymptotes for each of the examples. Okay, normally I just write VA for vertical asymptote, HA for horizontal asymptote, and OA for oblique asymptote. Let's first look at the vertical asymptotes. You can have more than one vertical asymptote. Look at your problem. You first want to see if you can factor anything and cancel anything out. So make sure you reduce your problem first before you find any vertical asymptotes. It will change your answer. In this one, there is nothing to cancel, so I'm going to go ahead and just begin. To find the vertical asymptotes, you set the denominator equal to 0. And then just solve it. That's why you may have more than one answer. If you have a quadratic or, cubic equation, you're going to get more than one answer. You'll have more than one vertical asymptote. And this one is just a linear equation, so we'll have one answer. So we'll add 6 and divide by 2. Okay, and it is a vertical line on your graph. Usually when you see it on a graph, it's marked with a dashed line. So you want it to be a whole equation here, x equals 3 for a vertical line. Okay, so that's my vertical asymptote. The horizontal asymptote, there's 3 different situations. I'm going to be doing 3 different examples, so you'll see all 3 types of situations. What you want to do is look at the degree of the top and look at the degree of the bottom. The degree on top here is 1. The degree on bottom here is 1, so they're the same. If you have the same degree on top and bottom, you're just going to use the leading coefficients to tell you your answer. Okay, and it's a horizontal asymptote, so it's going to be a horizontal line. You need to start it with y equals. Okay, so y equals, since they were the same degree on top and bottom, we're using the leading coefficients. So we'll do 4 divided by 2, and of course you can reduce that. So we get y equals 2 for an answer. For horizontal asymptotes, there's going to be at most one horizontal asymptote in your answer. Okay. And same with oblique asymptote. This one's actually very specific. The only time you'll have an oblique asymptote, you'll look at the degrees, and if the degree on top is 1 higher than the degree on bottom, then you have an oblique asymptote. So since they were the same in this problem, we don't have an oblique asymptote. Okay, so you'll notice if you end up having a horizontal asymptote, you won't have an oblique asymptote. If you have an oblique asymptote, you won't have a horizontal asymptote. So you'll never have them both at the same time, and some problems don't have either one of them. Okay, so we'll take a look at a few more examples. Part B, I've got f of x equals 3 over x squared minus 5. Okay. Again, before you attempt to find the vertical asymptote, just take a look at it. Are there any factoring that you need to do? Does anything reduce? Okay, in this one, nothing's going to reduce, so we can go ahead and get started. I'm just going to put VA here for vertical asymptote, and we know we're going to set the denominator equal to 0 and solve. Okay, well, it almost looks like a difference of 2 squares, but 5 is not a perfect square, so we can't factor it, but we can go ahead and solve it still. We can add 5. And then to cancel out the square, we'll take the square root. Remember, when you do that, you need to remember to put a plus or minus. So actually we get two different vertical asymptotes in this one. We have x equals positive square root of 5 and x equals negative square root of 5. You can leave them written together as I did here, or you can write them separately. All right, horizontal asymptote. Okay, again, look at your degrees. The degree on top, well, we don't have a variable, so the degree is 0. The degree on bottom is 2, so the top degree is smaller than the bottom degree. Whenever the top is smaller, 0 is your horizontal asymptote. Now remember, it's a line, so you want to put y equals 0. And then oblique asymptote. Okay, well, that's only going to happen when the top degree is 1 higher than the bottom degree, and that is not the case here, so there's none for our oblique asymptote. Okay, so I'm going to show you one more. Part C, they give me f of x equals x squared plus 2x plus 1 all over x minus 1. Okay, remember, before we get started with our vertical asymptotes, we do need to make sure that it doesn't reduce. See if we can factor anything. Okay, we can factor the top, so I just want to check this one to make sure I don't need to cancel anything out. Okay, so that middle term is the sum. My c over here is the product. Okay, so what two numbers multiply and I get 1? When I add them, I get 2. Well, 1 and 1. So this reduces x plus 1, or factors, excuse me, and x plus 1. And when we write it out, we see that it does not reduce because we do not have the same factors on top and bottom. So we can't cancel anything out, but we needed to make sure that we couldn't do so. If you can cancel, remember, it's very important to do so before you find your vertical asymptotes because it changes your answer. Okay, vertical asymptote, we'll set the denominator equal to 0, and we get x equals 1. The horizontal asymptote, we're going to look at the degrees. It doesn't matter. Well, let's look at the original problem so that we can easily see the degree on top and bottom. Okay, so the degree on top is 2. The degree on bottom is 1. Now the top degree is higher than the bottom degree. When that happens, there are no horizontal asymptotes. Okay, and then our oblique asymptote. Okay, well, in this one, we are going to have an oblique asymptote. Remember, if the top is 1 degree higher than the bottom, we're going to have an oblique asymptote. And the way you find them is with polynomial division. So we're going to go ahead and divide these. Notice we can use synthetic division here, so I'm going to set that up. I'll put a 1 in the box. Remember, change the sign. None of the terms are missing on top, so we're going to put the coefficients. 1, 2, and 1. Bring down that first coefficient. 1 times 1 is 1. Add them. 3 times 1 is 3. Add them. Okay, and you're going to rewrite it just like we did in the last section. It started with degree 2, so we're going to start with degree 1 when we rewrite it. So we have 1x, or just x, plus 3, and then this number is the remainder. If you're writing the oblique asymptote, you leave off the remainder. Okay, so you're going to put a y equals in front because it's an equation of a line, and this is our oblique asymptote. Okay, so this gives you a clear picture of the types of problems that you'll see in the section. Notice, again, let's just look at the horizontal asymptotes. the horizontal asymptote, if the degrees are the same, you're going to use the leading coefficients to find your asymptote. If the degree on top was smaller, it's automatically y equals 0. And if the degree on top was bigger, the answer was none for your horizontal asymptotes. Okay, so try out the examples and let me know if you have any questions.